how many have ever heard of a permutation? Heard the word permutation before? Okay, not a mutation, but a permutation. All right, let's put this into practical terms. Okay, I need 4 volunteers.
Oh,
Okay. Abby, Elijah, Jacob, and Talia. Come here.
what?
Okay.
Yeah.
Here's what we're gonna do. Okay, we have. This is permutations, by the way. Okay.
Oh, that's how you do it.
Okay, permutations.
Wait, Mr. Kersey?
Okay, no problem with today's date. Okay, 2-2. Okay, that's also a palindrome. You know what a palindrome is? What's a palindrome?
Like a word spelled forward, backwards, and all the same words.
This is a palindrome. What does it say forward? What does it say backward? Yeah, isn't that cool?
Oh, and this entire week is a taco cat or a permutation.
This week is a taco cat. Okay, whatever. All right, so here's what I have. I have Jacob. I have Elijah. I have Talia. And I have Abby. Okay. Now, here's what I want them to do. Okay. I want them to line up in as many different ways as possible. In other words, let's say you 4 had a contest. Okay. How many different ways could you come in first, second, third, or fourth? And I want you guys to write them down just using the first letter. Okay, let's figure one out. Go. You say 4, Abby? Okay, well, let's see. Line up. Jacob is first. Okay, so here's one. Jacob.
No.
Who's second?
You're in the right order.
Elijah. Who's third? And who's, okay, there's one. Good. There's one. Give me another one. Okay, now, well, we have Jacob is first. And now we have Talia is second. And we have Abby is third. And then who is last? Elijah. Okay, give me another one. Oh, we have Abby is first, Talia is second, Elijah, and then Jacob. Okay.
Let me first.
There's probably
Find another one. Okay. Here's another one. Talia is first, Abby is second, Elijah is third, and Jacob is fourth. Okay.
Mr. Kersey, I think there's 16 ways.
That looks like half.
No.
Hey, are there more ways?
Yes.
Yes.
Well, let's figure it out. Come
More
on.
ways to say.
Quit talking. Quit wasting time. Let's go.
Okay, just.
Okay, we have Elijah is first. We'll do this one up here. Elijah is first. We have Jacob is second. Who's third? Abby, and then Talia. Okay. Is there another way?
I think so.
Yeah.
Okay.
No.
Well, let's figure it out.
Wait,
There's
it's
no.
Guys, just look on the board.
Okay. Here's something that we need to remember. Okay, because I said first, second, third, and fourth, is the order that they're in important?
No.
Listen to what I just said. Is the order that they are in important?
Yes.
It is very important. Okay, we have Jacob. Let's see. We have Jacob, Abby, Talia, Elijah. Okay.
Jacob. I feel like there's another one.
Yeah.
There is.
Yeah.
Why is there a
Wait,
no,
Jacob.
It's
Abby,
Abby, Talia, Jacob.
Wait, me, Abby, Talia. Wait, no.
Oh.
Wait.
Oh.
Wait, no. What?
Yeah.
Okay. I'm going to stop you guys. Okay, so have a seat. Have a seat. There are lots of different ways. We're going to figure out exactly how many ways. Okay. But would it have taken them quite a bit more time to figure out that how many? What if I had put 8 people up there?
Oh.
It would have been
64.
a long time.
It might be 64.
Okay. Now let's look at how we figure this out. Okay. We have what is called well, before we get to that, okay, how many different, we have 4 people, right? We have Jacob, we had Abby, we had Talia, and we had Elijah, okay? In that first position, how many different people could there have been? Could Abby have been there?
Yeah.
Could Talia have been there?
Yeah.
Could Elijah have been there? Could Jacob have been there? How many is that?
4.
There are 4. Well, regardless of who is in that first position, whether it be Jacob, whether it be Abby, whether it be Talia, whether it be Elijah, how many are left for the second position?
2, 3.
Somebody said it. How many? 3. There are 3 possibilities. If I take whoever it is, it doesn't matter who, how many are available for that third position? 2. And how many would be left for the fourth position? 1. Okay? Now if I multiply these, 4 times 3 is 12 times 2 is 24 times 1. There would be 24 possible ways I could arrange those 4 people. Okay? Now if I had let them figure out how many there were up here, okay, it probably would have taken them a while, but they could have eventually figured it out, couldn't they?
Yeah.
Okay? Okay, when we have this, okay, first of all, with a permutation, okay, this is important. Order is important. Okay? Order is very important. Now, I could have said how many ways can they arrange where the order wasn't important, and that would have been a much lower number. Okay? I'll explain what that means when we get to that section. Okay? So when we have a permutation, okay, we are going to, does everybody have this written down?
No.
Okay. Are we good now?
Yes.
Yeah? Okay. This is what we call, when we have a number that goes all the way down to 1. Okay? Let's just say let's say I put 8 people up there. And I wanted to figure out how many different ways 8 people could line up from first through 8th place. What do you think it is? How many different ways?
First is 8.
Okay, we would have 8 times what? Times 7, times what? Times 6, times 5, times 4, times 3, all the way down to what?
1.
Okay, now this is going to be a big number, of course, okay? But here's the deal, okay? When we have a number that goes 1 down every time we multiply it all the way down to 1, that is what we call a factorial, okay? And a factorial is represented by an exclamation point, okay? So another way of writing 8 all the way down to 1 would be what? 8 factorial. It doesn't mean 8 with an exclamation point, so you say it loud like 8! Okay? That's not what that means. Okay? That just means 8 times 7 times 6. So what would this mean, people? What would this mean?
6.
5 times 4 times what? 3 times 2 times 1. Okay? What would this mean? 200 times 199 times 198 all the way down to 1. Okay? That's a ginormous number, by the way.
Imagine writing that.
Oh,
Is that
no,
over
no,
a
no.
million?
I'm doing the 8
Oh,
one,
that's-
that's like already.
Yeah, way over. Okay, so do you understand what factorial means?
Yeah.
Who said no?
I kind of blanked out when you said let's start.
Okay, so if I have a factorial, basically,
Wait, no, Miss Chris,
when
I'm
you
done writing.
when you see an exclamation point after a number, it means you multiply it by 1 less than that number, all the way down to 1. Okay? So, Abby, for example, if you saw what you guys were up there in the front, that was what we would call a 4 factorial. That means there were 4 possibilities for first place, 3 possibilities for second place, 2, and then 1. And that equals 24. Okay? That's what a factorial means, right? Right?
I get it. Yeah.
Okay. So let's say I have, let's take the word, or let's see.
Bob.
Jerry.
All right, let's do this. Let's say I take the word Chase.
Chase.
Okay? How many different ways can I arrange those letters, do you think? They don't have to form words, just how many different ways could I do it?
5.
Well, figure it out. Figure out how many different ways I could arrange those letters.
Well, that's difficult. 5 different ways?
25.
No.
Wait.
Chase has an answer. Both Chases have an answer, oddly enough. Some of you didn't write anything down. Some of you are staring into the abyss.
Yay.
Okay, sorry, it's not going to help you.
It's a long way.
Okay, so Chase, you had your hand up first. How many different choices do I have for the first letter?
Well, for the first one, it's
It could be C, it could be H, it could be A, it could be S or E, right? So how many is that?
5.
5. How many for the second one? And the third one? So this is the same as what? 5 factorial, right?
Yeah.
Okay, what's 5 times 4?
20.
What's 20 times 3?
60.
What's 60 times 2?
120.
What's 120 times 1?
120.
Okay, so there were 120 different ways that I could write the word chase. Okay?
That take you a long time.
Does that make sense?
Yeah, I get it now.
Okay, now, let's say, I'll wait till you're done talking. Let's say I have some numbers that have an operation between them. Let's say I had something like this. 4 factorial times 3 factorial. Okay? Let's just figure out, first of all, how many can think of a way I can solve this? How many of you think I should multiply these two first and do 12 factorial?
No.
That might be one way. How many of you think I should find what the value of each factorial is first and then multiply? Let's try it both ways and see if we get the same answer, okay? All right, let's do 4 factorial. What is 4 factorial? 4 times 3 times 2 times 1 times 3 times 2 times 1. What's 4 times 3?
12.
12. What's 12 times 2?
24.
24 times, what's 3 times 2?
6.
What's 6 times 1?
6.
6.
6 times.
What is 24 times 6?
Yeah, 44.
Huh?
144.
144.
How did you know that?
Now,
It's because it would be
let's find 12 factorial. 12 times 11 times 10 times 9 times 8. Do you already know by looking at that that's going to be much, much higher than 144?
Well, because 12 times 11.
Why
That's already 132, right?
does your 1 look like a...
And 132 times 10 would already be
Well, that's something that...
4 digits, right? Okay? So the way you want to do a problem like this, you find the value of each of these first, and then you put them together. Okay? Now, you're going to be able to use calculators today. However,
Oh, you need a show.
if you use a calculator, you show me exactly what you put in the calculator. So, if you did, for example, 3 factorial times 7 factorial, okay? You need to show me, I did 3 times 2 times 1, which is 6, times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is a big number. Make sense?
Put the exclamation mark in the calculator.
There is a button like that, but I still want you to show me. There's a factorial button, yeah.
So you
Okay.
can just write it in paper.
All right. So let's say this. How many of you guys see license plates?
Yes, sir.
Okay. So when you see a license plate, typically in Colorado, okay, you have how many digits?
6.
There's 6 digits, okay? There's 6 digits on a license plate, okay? Now, this one can be a number or a letter.
You should write that.
So think about this for a second. How many different ways? Okay, I'll tell you what. I'm going to give a premium sucker, to whoever can figure out. Remember, it can be number or letter. How many different license plates can we come up with? None can repeat.
Wait, is it whoever does it first?
Actually, no, the numbers can repeat. No letters can repeat.
Wait, for the first one? Or like the whole thing?
The whole thing. Let's see who can figure it out.
That's not happening.
Figure it out.
Can we use
I mean, there's about how many
No, I
million
mean-
people in Colorado?
Is it a lot?
So if every single person has a license plate, do you think there's enough license plates to go around?
But like the kids don't have license.
But let's say they did.
Wait, can we use a calculator?
Okay, get your calculators. Try it out. Let's see if you can get it.
Wait, is it the first person to do it?
Yep.
Oh. Not a chance. Okay, wait, I think I have the answer.
Write it down.
I got it.
No, you do not.
No way. Mr. Percy, can you be a number or a letter? Or only the first one?
Every single one. Hey, every digit can be a number or a letter. None of the letters can repeat. So think about that.
Wait, what number?
Wait, but that's.
I'm 6. Can you get me a
Got it.
calculator? Well, there's 1 and 9, so I'm using yours.
Is it like a 6 factorial?
You're gonna give it to me though.
Yeah, it's like
You didn't
26. There wasn't one in mine. So
I don't care.
Write down your answers, guys.
Even I have to go back there.
I see it's too small.
I think you should get out of his face.
What?
I have my answer.
Good. Sit down.
Holy mackerel.
Ow.
Oh yeah.
Oh, I got the wrong.
Mr. Piercy, I think I did it wrong. I think I did how many possible
I know.
things there could be.
Yeah, that's what I did. I got 700.
Okay.
I understand how, but I
Oh
thought
my
do
God.
that.
You do like the exclamation mark on this.
I did.
Mr. Kirsty.
Okay. How many of you are stuck? How many have an answer? Okay, write down your answers. Write them down. I'm going to give you 30 seconds. If you haven't figured it out in 30 seconds, you're not going to figure it out. I'm going to give you 30 more seconds, actually 25 more seconds. Write down your answer, and let's see who gets a premium sucker.
I have. Wait, do we get a premium sucker? We got it right.
Yeah.
I thought it was just
The first one. Okay. Well, let's see here. Now, who has an answer?
Mr. Kersey, just give us one.
No more time.
What? The desperate.
Okay, how many numbers can they be if they're one digit?
6, 9,
1, 2,
9,
3, 4, 5, 6, 7, 8, 9, 0. How many is that? It's 10. How many letters are in the alphabet? 26. So for this first one, by the way, don't write any new answers. I'm not going to accept anything else. This first one will be what? 36 possibilities. Now, if no letter can repeat, we take one off. What's the next one going to be?
35.
And then 34, and then 33, and then 32,
36.
and then 31.
Oh, I know where.
Where'd you get?
So,
I understand.
I did it again and I got it, but I already
What's
put
the
it
answer?
down.
it was, let's see.
That's a big number.
That's like 14 million.
Oh, it was in the what?
So there would be 140 billion,
No, wait, right.
140 million, 240. Oh, wait, I put my comma in the wrong place. So 1,402,410,240. Did that cover enough people for Colorado?
Yeah.
Yeah.
Probably.
Okay.